Hello, this is just a quick ad hoc screencast looking at coherence measurements in Persyst. There's a few different places that you can make those measurements, and so we're just going to dive right in. I've just gone to the onset of a seizure here. I've already added a couple of coherence trends to this, and if I were to go to different places in this recording, we don't see a lot of change in the level of coherence between this, and of course I picked a channel to do the coherence measurement. Again, so we have T3 to an average 12, and T5 to an average 12. And here at the onset of the seizure, we can, if we want to look, we can right click on this, show values. You can see the coherence. 1 is maximum, 0 is minimum, and the frequency at which that maximum coherence occurs. So if we go back here, we'll see it's at different frequencies. And one of the things to keep in mind with coherence, of course, it's like other measurements of this nature, it's not really looking at amplitude. So if you have low amplitude signals, then you may see coherence measurements that aren't that relevant. So it's not uncommon to do coherence measurements for a selected range of EEG, but of course you can trend them to for any number of channels. Of course you can replicate trends and have a full page and a bipolar or an average reference making those measurements. And since I did do an average reference here, one thing to point out is I went ahead and I modified the trending montage. The way I did that is I went to the BP longitudinal montage. This is one that I have with some double distance channels added. Saved it as a new one and added some average reference channels to that. So if I go to other montages, and I named it BP long and ref. And so I've got my bipolar and longitudinal channels, and I have my average 12. And that just means it's going to calculate them for these as well. It makes for a larger results file, but that's fine for what I'm doing. All right, so when I go to Preferences, Modify Template, then I can open up the trend settings I want to change. Now in this case, I'm running the research package, which is a superset of the clinical ones. And under Trend Preferences, I get things like the calculation engines tab and so forth. So I can go in and modify the calculation engines. I was playing around a little bit with having a second FFT engine with different parameters for my coherence measurements, all sorts of things. So main thing to keep in mind is that when I modify this MMX file to add coherence trends, is I went ahead and picked my new montage here. It's grayed out because I've already trended this BP long and ref. And if I scroll down this, you'll see that I have my average 12 channels here and the pair of channels that I'm calculating that. It automatically adds this last pair when I've selected this in this trend configuration. So that's one way to do it. And happy to go through that in more detail, but that's essentially you're adding a trend and you're telling what channels to use. So another way to do coherence measurements is under the Tools menu you have Insight 2. And this is explained in the new Prism application notes, but I've gone to the same recording. I want to back up a little bit to the onset. And let's go ahead and apply some artifact reduction from the menu here. And I want to look at the coherence over a specified period of time, because as the seizure evolves, the frequencies, in this case, this one's evolving from faster to slower. So I want to pick something that's fairly stationary towards the onset of the seizure for this particular one. So I'm just going to right click on this. And I've already deselected fixed position of new cursors. You can do it either way. I tend to turn that off for this because when I insert the range, and I just selected insert range, and I'll go about as far as I want to go. So there's that, and I can grab these little carrots at the top and scooch them around. You can also right click on this, go to cursor control, and you can go to the properties, and you can change times very discreetly down to the millisecond, of course. So aside from all that, all I wanted to do is mark this. So I right click and insert range. So I've inserted that range and said, all right, I want to do this. And I've already picked my referential average 12 montage. It'll do it in any montage. You can do it in bipolar. That's perfectly fine. It depends on what your application is. So I'm using an average 12 montage. This just happens to be the primary spike detection montage. It's handy. It works for that. So let's right click on this, go to Insert Vertical Adornment, and I'm going to pick Frequency Domain Analysis. And right off the bat, I just get an FFT for that page, not the range, because when I go to Properties and I pick Data Ranges, it's selected by default to EEG page. So I'm just going to pick ranges visible. That's fine. And then when I click OK, you see that peak there, right around 10 hertz or so for that frequency. So again, it's not doing the whole page. It's doing just the range that I intended. You can see that changed the graph already. So with measurements, you want to say, well, this is what I'm measuring, and define that. The full page is fine, but you may have a lot of changes over that page, and it will not be as meaningful. So let's make this a coherence measurement, which is correlation by frequency, right? So if we go coherence separated, and I'm going to pick the channel, and let's pick T3, this one right here. That looks good. You can pick any channel you want. You can change them. Now, the next thing was the data ranges. I've already set that for my visible ranges. So first thing, coherence separated. There's coherence combined as well. There's phase encoded Fourier spectrum analysis. There's a whole series of application notes on this stuff, tons of tools. But let's just do coherence so we don't get too far off the path. As far as the data window type, it doesn't make a huge difference in what you're picking, but you can pick different data windows, essentially some smoothing. So let's go to data ranges. That's correct. Let's go to spectrum, 0 to 32 by default. We can just go up to 20 hertz, give us a little bit more room, or spread things out a little bit more. Now the shared axes tab, this is going to have three pieces to this. First, it's going to look at the FFT power so that I can pick a peak to do the analysis on. Next, it's going to show the phase relationships from 0 to 20 hertz, because I set that in my spectrum. I'm going to show the phase relationships of that, because it may have more or less correlation at a particular frequency or coherence, but there's a phase relationship there as well. So if it's 180 degrees out, it may be a dipole, right? That's oriented in a way that you have the phase 180 degrees or negative 180 degrees out. If it's closer to 90, it's a bit ambiguous. If it's much less than that, it's usually propagation delay. So I'm going to unselect this because the first column will be in microvolts, second column will be in plus or minus 180 degrees, last column will be 0 to 1 for coherence. So deselected that, click OK, and there we go, we've got it. So here's our FFT, first column, second one, there's our phase relationships, and you notice here that we picked our channel as T3 that we're doing those comparisons with, and those are blank for those two, which makes sense, right? It certainly does have power, so it calculates the FFT. Phase relationships and correlation. So let's get some numbers from this. I'm just going to pick the peak, and you can pick that wherever you want, but I'm just going to right-click on this and insert cursor, and I can grab that caret at the top, and I can move it around. I'm just going to line that right up with the peak of that. You can pick wherever you want to go. So I'm going to do that, right-click. Now I'm going to put in another vertical adornment. FDA table, FDA is frequency domain analysis. So we could have just called it a table, but it's an FDA table, right? So let's move this over because everything kind of got squished. And if you notice, the arrow becomes a two-headed arrow. There's no visible boundary there, but if you put it between those, it'll become a two-headed arrow. You click, and you can move these things around. You adjust the spacing that you want. Do that on the left side. There we go. And a little bit more. All right. Grab that thing, move it over. All right. So what do we got? If we look at this, let's say T5 versus T3. If we go over and read this, peak at the frequency I've selected, 10.25 hertz here. That's listed down at the bottom where I placed that cursor. Amplitude 14.8, and that's at that frequency because there's a mix of other frequencies in there. Not a lot. It's pretty low to the left and right of that, but at that frequency, that's the amplitude. And phase relationship, pretty close, -3 degrees. That's that middle one. And again, this is by frequency. We're looking 0 to 20 hertz. And so this is the phase relationship across those frequencies. And this is the correlation, or the coherence by frequency, right? So here we can see that it's maximal, pretty much from 10 up to 15 hertz here. So there's the output, and you can look at that across channels. You can change the channel that it's doing the comparison with. So let's do T5. So I'm going to go right-click on Properties, and I'll just pick T5 to AV12. Again, you can use bipolar derivations as well. So, and now you can see this one has zeroed out, and I would expect these to look pretty similar. Yep. Instead of -3, it's gone to 3. Correlation, or coherence rather, is 1. That's the max. And those numbers go up and down depending on where you are on scalp. So that's another look at coherence measurements in Persyst. Now there's another thing that you can do is you can lay in trends with the channels. This may or may not be one application that you'd use for that, but you can right click on a channel, you can insert a trend, and let's pick a couple of frequency ones. Let's pick coherence average, and you see you have a question mark there. We haven't given it a channel yet, and we'll right click on this, insert trends. Some of them will do a channel for you, some will not. Easy to do though, we're going to do that in a minute. Let's do the spectrogram. Okay, so I'm going to double click on this, and I'm going to set spectrum. Oh, let's do 20 hertz again. Do 1 to 20 hertz. We'll do microvolts so that it's not using as much of that dynamic range. And that's just, well, for coherence it doesn't matter, but for spectrograms generally I won't use microvolt squared just because it squares all the values, and things that are higher tend to get bigger. Not really a consideration here because the values are all 0 to 1. Data, let's pick the first and second channel. Oh, let's go with it again. Let's do T3 and T5. Okay, and display is good, axes, okay. There it is. So there's the average coherence. If I wanted to view the values of this, I can just click View, Legend Bar, and if I right click and show values, just like we did in the trends, anywhere I click on this, it's going to give me the value. So let's configure this other one. This is the coherence spectrogram, right? Double click on that. And we'll go to spectrum, and let's pick 1 to 20 again. Data, we'll pick T3, T5. And we're just using that single-ended scale, 0 to 1 in blue. This reverse here would, of course, make everything backwards, where 1 would be the most faint color. So we have that clicked. Click OK, and there's the spectrogram. And the darker it is, as it gets towards the solid blue, it's going all the way to 1. So as we page back through this, you can see there's blocks where there's more or less coherence. And that doesn't relate to amplitudes. That's the thing just to keep in mind with coherence. It's correlation by frequency. It's not really looking at amplitude. So if you have a low frequency or a low amplitude signal or a high amplitude signal, one with things that really stand out, coherence is a separate question, is the correlation by frequency. Anyway, that's a quick look at those. This is Mike Guess, VP Research and Clinical Applications like this for Persyst. Feel free to contact me with any questions. Have a great day.